Hello, this is Lab 1 for Physics 2211. Let's get into it. What is velocity? Velocity is a vector quantity defined as the speed of an object in a given direction. It needs both speed and direction. Without one or the other, it is just a scalar quantity and not velocity. What is constant velocity? Constant velocity is the same as velocity, but it is neither speeding up, slowing down, nor changing directions. If either of these happens, it is no longer constant velocity, and maybe acceleration, if not just regular velocity. What does Newton's second law have to do with this? In simple words, Newton's second law states that an object at rest will remain at rest, and an object in motion will remain in motion, as long as no new force acts upon it. In other words, in order to achieve constant velocity, all forces acting on an object must achieve equilibrium, as shown in this diagram with gravity, friction, the force applied, and the normal as well, all acting in equilibrium on an object. There's also the equation for Newton's second law right here, where force equals the change in position over time. Now, how can we determine constant velocity? We already mentioned Newton's second law, how it affects velocity. Thus, we can use a kinematic position update formula to determine constant velocity. Here, the final position equals the initial position plus the change in velocity times time. In other words, acceleration times time. And so here's for the physical experiment, the video. Here I rolled a pink ball over a cardboard surface at a given constant velocity. How can we plot this? When we plot this, we kind of see how the object slows down and speeds up at different intervals, not necessarily a constant velocity. So does that mean that it wasn't constant, or why is this the case? Well, in simple terms, creating constant velocity in the real world requires a lot of preparation, and thus it tends to vary. In a computational model, however, we could do this a lot easier. In order to do it, though, we need the initial velocity of the ball and the time. We already have all of these data points established from the physical experiment. So now we have to do is find out what the time is and what the velocity is to input it for the data. In order to get the time, we need the final time that it took the ball to roll across the surface and the start time. If we go back, the final time was 1.8. 1.8 minus 0 equals 1.8 for t. For velocity, it can be found as speed over time. If we go for the final speed, you can see that it is 1.56. And time was 1.8 as earlier established. And because the direction is leftwards, the final velocity is 0.86 continuous meters per second. But why is it negative? Well, because the ball rolled left on typical in typical physics equation, the coordinate system always points, when it points up and right, it is a positive equation, and when it points down and left, it is negative. Now here's the computational view. Here you can see how the ball is rolling in the negative direction, but still forward in the sense of the left direction. Here it is rolling left with all the computations. The ball's velocity also equals the initial ball's velocity throughout the experiment, since it did not change at all. Here's the difference in both of them. Put it in an Excel sheet. We have the computational points and the physical points. Here's a graph. You can notice how in a physical experiment the ball rolled not necessarily at a constant velocity, but overall rolled downward and down to the left. And in the computational experiment, it was a lot more direct. What if the axes were flipped, though? Well, all that would mean is that the ball is rolling in the positive direction, or so right, and not the left. Here you can see the difference in graphs. What does it mean though? Can we determine how many forces acted on the object? No, we cannot. We cannot precisely determine the number of forces knowing only the net force. It could be 1 force as shown here, 2 that equal the same initial force, or 3, or it could also be 10, 100, or even infinite. It just cannot be determined. Thank you.